Hello viewers, in today's class we are going to discuss these two important definite integrals, right? And here we'll write the values of these two important integrals directly with the help of formula, right? So let us start. Now see, here the two integrals are 0 to pi by 2 dx over 4 cos x plus 3 sin x. Here we have 0 to pi by 2 dx divided by 5 cos x plus 3 sin x, right? So if we closely observe the form of these two integrals, then we can easily realize that the limits are from 0 to pi by 2, and the integral is of this form, that is dx. Here we have dx, and the integral is 1 over a cos x plus b sin x, right? And a and b are greater than 0, right? So the form of these two type of integrals is similar to this one, right? So we can solve this type of integral by taking the substitution as t is equal to tan x over 2, right? So we have already solved these type of problems in the usual way in our previous videos. So here if we solve this integral in the usual manner, then we have to make this substitution, that is t is equal to tan x by 2, and then we can convert this integral in terms of t, right? But here we'll directly write the value of this integral, right? And then we'll apply that formula to get the values of these two integrals. So now the direct result for this integral can be written like this, right? So we have first the term 1 over square root of a square plus b square, right? So here we have a and here we have b, right? Then we can take log and see inside this log we have two terms. The first one is the numerator and then the denominator, right? So first we'll write the numerator. So the numerator is it can be written as, first we'll write a plus b, and here also we can write a plus b, right? And then here we'll write plus square root of this term, right? That is a square plus b square. So here we'll write a square plus b square, and here we'll write negative sign, and the same term will appear here, and we have a square plus b square, right? So the value of this integral is given by this expression. So now let us apply this rule to these two integrals. Now if we compare this integral with this one, then the value of a is 4 and the value of b is 3, right? Then we have the term square root of a square plus b square. So square root of a square plus b square is square root of 4 square plus 3 square, and here we have 16 plus 9, that is square root of 25, that is equal to 5, right? So the direct value of this integral is equal to 1 over square root of a square plus b square. So here we have simply 5. Then we have log of a plus b. So a plus b is 4 plus 3, that is equal to 7. So now here we have a plus b, that is 7, plus square root of a square plus b square, that is equal to 5. So here we have 5, and in the denominator we have 7 a plus b minus 5, right? So now we have this term. So we can simplify it. 1 over 5 log of, this is 12, this is 2, and here we have 1 over 5 log of 6, right? So this is 2 6 are 12. So the value of this integral is equal to 1 over 5 log of 6. So now let us calculate the value of this integral. Now comparing this integral with this one, the value of a is 5 and the value of b is 3, right? And the value of this term, that is the square root of a square plus b square, is square root of 5 square plus 3 square. So this is square root of 25 plus 9, that is the square root of 34, right? Now we can write the value of this integral by making use of this result. So we have 1 over square root of 34, then we have log, and now we can write the numerator a plus b. So a plus b is 5 plus 3, that is equal to 8, right? So here we have 8, and then we have plus square root of a square plus b square. So this is square root of 34, and here we have a plus b, that is 8 minus square root of 34, right? So we can see that how simply we can write the values of these type of integrals by making use of this result. And always remember that here the limit should be 0 to pi by 2. The lower limit is 0, upper limit is pi by 2, and provided a and b must be greater than 0.